I had told you in the previous session, the computer understands only binary bits, that is zeros and ones. So when you write a program, either in assembly language or in a or in a high level language, it needs to be converted into ones and zeros, which is the machine level language. In order to do that, we require programs called as language translators. Language translators are programs or software or system softwares which convert programs written in a high level language or assembly language to object or machine code. So commonly used translators are compilers, interpreters, and assemblers. Let's understand what is an assembler first. An assembler is a system software. Why is it a system software? It needs to have detailed knowledge of the hardware so that it can translate the instructions correctly to work on that particular hardware. So assembler is a system software which translates or converts a program written in assembly language to machine level language in terms of zeros and ones. Examples of assembler softwares are TASM, which stands for Turbo Assembler, and MASM, which stands for Microsoft Macro Assembler. Now let's look at the next software. The next software we would be interested obviously would be the compiler. So a compiler is a system software which converts a program written in a high level language like say C, C++, and so on into machine language or object code. For now, just assume that machine language and object code are same. It's almost the same, but there's a small difference. What a compiler does is assume this is your entire program, this page. It will take one line, process it, take the next line, process it. Take this entire page consisting of program or instructions and convert it into machine level language, provided your syntax and logic, not logic, provided your syntax is correct. So once your syntax and semantics, that means once the program makes sense, it converts it into a machine code. Examples of languages which use compiler are C, C++, COBOL, and Fortran. So compiler converts a high level language into machine language, the complete program into object or machine code, after obviously verifying the syntax and semantics. Now we come to a software called as the interpreter, which does the job same to a high level language what a compiler does, but with a few basic differences. An interpreter also translates a program written in high level language to machine level language. The difference is it takes one line, say for example, this is one line, it takes this line, converts it into machine language and executes that line. Once it executes, it comes to the next line, converts this and then executes it. Whereas the compiler would convert the complete thing into machine language and then execute the program. Whereas this fellow will convert line, execute it. Then there is one more difference. If there are errors in this, the compiler will list all the errors after trying to compile as much as possible. In an interpreter, whenever it encounters an error, some syntax mistake, instead of putting a full stop, you put a semicolon. At that particular line itself, it will halt and say there is a error. The drawback of an interpreter is the code is slower compared to a compiled code. Why is it slower? Because in compiled code, the complete thing is converted into machine language and it can run at one shot. Here, for each line, it takes time to convert it, execute. Read the next line, convert it, execute. Whereas the compiler has already converted the entire thing into machine language and it is executing. Now, a compiler will create an output file which can be run on the machine. Generally on Windows it will be .exe, on Linux it will be a.out. Whereas an interpreter does not create an executable or a .exe or a.out file. Another interesting thing with the interpreter, every time you need to run the program, the interpreter also needs to be in main memory to run it. Whereas with the compiler, you just need to compile it into object code or machine code once and rerun that object code as many times as you require. Whereas with the interpreter, that many times you'll need to load the interpreter to convert it into a executable program or to execute the program. But still, interpreter is widely used. Examples of languages which use interpreter are Java, Basic, Python, and Ruby. Now we'll take a look at the last piece of conceptual information called as the utility software. The best way to understand utility software is think of antivirus software, software to clean your registry, software to delete junk files or waste files on your machine. So utility software is a software which actually doesn't do directly any work for you, but it helps to do tasks like taking automatic backup of your data, automatic backup of your programs, checking and preventing in virus infection to your machine. So examples of utility programs could be your text editor like TextPad, Notepad, antivirus software. To reduce disk space, you could be using a software called as software or disk compression software, which reduces the size of your data on your machine, thereby saving space. So utility is software which provide indirect services which help you in the operation of a computer.